Okay, welcome back. What I want to continue to look at is, wait me for a second, is Unit 307, and we're looking at live testing 2, okay? Now you'll see that session 8 was live testing 1. This is session 9, live testing 2, okay? Now, you need to take the time to actually read this through and to look at the work being presented in the PowerPoints. Now all I'm going to do here, I don't need to read this out to you, you can read this for yourselves, okay? Okay. And just make sure that we are having a knowledge as to what we are meant to be doing and what the benefits of these PowerPoints hope to provide you with, okay? Now session 9, now let me be quite clear. In this session, the student will identify the requirements for measurement of prospective fault current, specify the methods for determining prospective fault current, verify the suitability of protective devices for prospective fault currents, specify methods for testing the correct operation of residual current devices, state the reasons for verifying phase sequence, state the need for functional testing, okay? Right, prospective short circuit current, PSCC. The usual relevant points are at distribution boards, as we are seeking to determine the capability of the equipment in use to withstand high fault currents. Now, when we talk about high fault current, it means that when we have a short circuit between live and the neutral conductor, the current within at that point is very high, and sometimes it can blow your control systems off the wall. It's that strong or powerful. The prospective fault current (PFC) test enables us to judge whether the breaking capacity of switchgear and protective devices are appropriate, and the tests carried out on RCDs enable us to judge whether the disconnection time is appropriate for the setting of the device. The prospective fault current is a single name given to cover two specific tests. Prospective short circuit test. This takes place between live conductors. Prospective earth fault test. This takes place to earth. Okay. Now it is important that the inspector recognizes that a distribution board may contain a range of protective devices having a range of breaking capacities. Okay. Okay. So we're just trying to make sure I'm in range here, okay, and full screen. Now, look at these regulations, and you need to make sure that in regards to the regulation 612.11, etc., etc., that they're still relevant in regards to the current 18th edition IEEE regulations. Okay, now all these regulations need to be taken into account to make sure that you are familiar with any changes which may have taken place in the new or any later editions yet to come out. Okay, that is your job. Make sure you are compliant at all times with the IEEE regs. Now here we have our main intake position, okay, and you can read this for yourself. All switchgear has a breaking capacity figure quoted on it, okay. Now when we look at these, each of these here will have a current handling capacity at short circuit possible points, okay, and they are designed to withstand a given short circuit at a given current rate. Now these are your bus bars. Now bus bars they don't actually blow, but they can melt if you have a situation where there is a short circuit in excess of a given value. It will cause the bus bar to melt. That bus bar will then need to be changed completely excuse me, for a new copper element, okay, or I should say segment. Now be aware that when it says here, when this amount of current flows, explosion can occur. This test process is dangerous. Therefore, regulation 14 applies. Do not put yours or anyone else's life in danger. Now, excess current can cause massive problems and massive explosions. That is why it's very important that we have good earthing, good equipment in place to handle the capacity of any short circuit, and that our equipment will provide us with the protection that will trip the circuit to minimize damage to the circuit overall. Okay. And we have prospective earth fault current test. Now the OSG, as the on-site guide recommends that PFC tests are carried out with all main bondings in place. That is to make sure that if a fault occurs on some pipe work, that it does not cause damage to or injury to anybody else, that it will go straight down to earth, or in the protective mechanisms will allow the protective device to operate, thereby removing any electrical potential. Now here we are looking at using a 2-lead test instrument. Now I'm not going to go for this. You would have done this in the lab or in your workshop. So this is something now for you to do. And all this is showing you here is how the terminals are applied in each case, okay? Okay. And again here, using a 3-lead test instrument, okay? Make sure you're familiar with this yourselves. And for the prospective short circuit test, the neutral lead and the protective earth PE lead should both be connected to the neutral of the supply. Okay. Okay. Now, this is something that you should be familiar with. I don't need to be trying to identify this because you're level 3 now. So I don't see the reason to be extremely specific. You should all be familiar with the stuff and know how to apply and know how to use the testers, etc. Okay. Now, determining PFC can by calculation. If you have already measured the earth fault loop impedance, then the prospective earth fault count can be calculated using Ohm's law. Now, the earth fault count can be calculated using IPEFC equals V out over ZE, voltage over ZE. Okay. Now you notice that we're using 230 volts. Now, bearing in mind that ZE is 0.14, you can see that the count here is 1643 amps. That is a lot of current, okay? And sometimes it reaches excessively higher than that, depending on the circuit and the application of the fault. Now, for a 10CS system, the prospective earth fault current and the prospective short circuit current values are the same. Now, recording results. The results are recorded in the box headed the nature of supply parameters which require the PFC at the origin to be recorded. The value that should be recorded is the greater of either the short circuit current between the live conductors or the earthfall count between the line conductors and the met. Any other necessary values can be recorded on the schedule of test results. Okay. Okay. An answer is unlikely, unlike any other protected device, and will only operate under earthfall conditions. Now, these are things that you should now be familiar with. Okay. Now again here, I don't want to be reading this out to you. You can deal with this yourselves. Okay, I've done enough reading for you now. Okay. Now here, after the testing, and again, you'll need to comply with the regulations and the standards. Okay, make sure you are up to date. Okay. Okay. And after the testing, the following procedures should be followed for testing. And again, make sure you are compliant with the current IE regulations in regards to the timing. Phase rotation. Okay. Again, regulation 612.12 needs to make sure that you are compliant with this and check that you are up to date in regards to the current regulations at all times. Okay. Okay. These are just some of the testing tools you will need. verification of voltage drop. Okay, I need to read it out to you. You can read it for yourselves. Okay. And here we have functional testing. Okay. Functional testing. Okay. Okay, I hope you found this useful. That's it for now. Okay, talk to you soon. Have a good day. Bye bye.